during the last lecture, we started talking about object-oriented programming. I created a simple object, C-rectangle, which has two methods, so circumference and move. And in declaration, we have all fields or attributes which are required to represent this object. So to draw it and to calculate some simple geometrical relationship. And so object-oriented programming is strictly connected with something which is called hermetization or encapsulation. So all attributes are private, so they are not directly accessible by the user, but it can modify these values by methods, by public methods. So here we have two methods, in fact, two methods I have defined yesterday. So in method, if we want to refer to attribute, we basically use the attribute name, or we can use pointer this. So both of this form are equally good. Some programmers to underline that this is part of the object use always this, but you don't skip it. You can skip it. Okay. No, method. So it doesn't. We can have different methods. So I can have methods which is public or private or next. So today I will tell you about different type of access modifier. So there is also access modifier which is called protected. But I can create, for example, void helper func. So we have helper function, or maybe set x. And in this function, I can, for example, write x is equal to 0 or reset x. So even this method is private, so it doesn't matter. Every method can modify all attributes. But from user perspective, so if you have an object, so we created it, you have direct access, so you can call directly only these methods which are public. Of course, you can create a public variable, so an attribute which has access modifier which is public. So in this case, I can write rect remember that this name can be arbitrary, so it doesn't need to have a public word in variable name, but it is allowed But in this case, I broke the encapsulation principle. So this variable is not hermetized. So if it is not hermetized, the user can do everything with this variable. When we use object-oriented programming, we assume that variable should be initialized indirectly by using method, because sometimes in more complex application, usually the change of variable name may require some additional steps. So for example, we have to verify whether the variable value is okay, or we have to run some other functions to update something. Yeah. So from this perspective, direct access to variable shouldn't be used. Yeah, and it breaks the encapsulation principle. So therefore, I encourage you not to use the public variables. The second, okay, so here I can have method which is private. This method modify the value of, let's say, attribute X. But I can refer to this method. Of course, it makes no sense here, but reset X. So I can call this method from another method, like standard function. Of course, I can use this as well. So it means that I call the reset X method, this method, from, you know, my move method. But if I try to call rect reset X method for the object, because this method is private, I can do it. I'm not allowed to call this method directly because it is private. Okay, but let's clean this code. Yesterday, I created something which is called constructor, and now I'd like to tell you several things about this issue. So look, when you create object, and it is before it will be created, or in the time it is created, let's say that, the constructor is called. So this function or this method, it's not a pure method, but the constructor will be executed. So in creation time, this method will be called. So here I can specify what should be done on object creation. So what should be done? The object should be initialized. In C++, when you create, let's say, int x, okay, what is the value of x here? So when I print cout x, no, it's not 0, okay, because this value is not initialized. So when the memory is allocated for this variable, its value is value which is presented in in given area of memory. So it can be, yeah, garbage. So remainings of the previous process or variable which was previously stored there. I told you about this issue several weeks ago. So if you create variable, it is not initialized. To use object safely and in object-oriented programming, the safe issue is very important. So I'd like to deliver object or class which can be run safely by the user, and he or she doesn't need to know what are the default values for arguments. So it's similar to device with some presets. So when you turn device on, you don't need to set additional, or configure it. It has default configuration. If you want to modify something, okay, you can do it, but the proper initialization with default parameters guarantee that the object will not be broken, okay? Or can be used as a, let's say, demo. So when we have rectangle, we should initialize all these elements to use this object, easily. Yeah? And then user can modify some of them. So only those parameters which he wants to tune. Okay, so here I have these values. So first I will show you the way which will be easy to understand for you. But after that, I will show you the way how arguments or attributes are initialized properly. Yeah. Okay. So I can do it. Okay. So I can initialize height by with 1, white with 1, x with 0, y with 0, angle with 0, r with let's say 255, g with 255, and b with 255, and it's not hidden. Okay, so in this case, this code will be run on object creation. So after that, I can run my code, and you can see that the value is 4, yeah, because every dimension is 1. But properly, it should be defined quite different. So the attributes should be defined on initialization list. So initialization list is something like that. So I have to mention the attributes here on the list, and for every attribute I should define the value. Yeah? So x0, y0, angle 0, r0, oh, 255, g0, 255, b255 is in false. Okay. So this code does the same, but in some cases, this method is faster than initialization object on this way. I will tell you something about this later, but this method is the same or faster than this way of initialization. This form is called initialization list. So what should be here? So for initialization attributes with fixed value, it is enough. So the constructor body may be left empty. But sometimes a value of attributes is calculated. Yeah, so we have some loop and we have to calculate it. So in this case, the attributes which values should be calculated by running some extra code should be initialized in constructor body. Otherwise, it should be initialized by using initialization list. Okay. Now I'd like to tell you something about nomenclature. Usually, or okay, it depends on habits, but some programmers, and you can find it in code from, for example, Google, try to mark attributes which belongs to class, so and distinguish them from variables which are local variables of object or arguments by adding underscore here. So we have the all attributes has the underscore. So I can modify it here. So I should. So of course, this is only convention, but in code we can easily distinguish variables which are so visually distinguish variables which belongs to class. So they are class attributes from variables which are which have different origin. Yeah. Okay, my editor also highlight this variable. So we have a red color, so we can visually distinguish them from, for example, local variables. But if you want, I think it's a good habit to use underscores. There are different convention because some programmers use not underscore, but for example, the prefix m underscore, so it denotes a member variable. Okay, it's it's up to you, but I think you can try to do it like this. Okay, so we have constructor, we have circumference. What about other methods? Because all elements are private. So they are private. To modify them, I have to have a set of setters, and to read them, I should have a set of methods which are called getters. Okay, in Java, for example, there is, for some members, there is an automatic method which creates setter and getter for all members. In C++, we don't have this, but okay, we can do it, in very strict way, or we can do it, more flexible. So, for example, usually we modify 2 dimensions at the same time. Yeah, so maybe it's reasonable to have set size method, and we have float so we have setter set size, and we can define it. So refactor at definition, we can define it. So I can write height is equal, and the same. Is equal. So this is setter, not pure setter, because usually pure setter can change only a single variable. But I think when we have so many attributes, it's good to have okay, set pose. So I have X and I have Y. Huh? So here I can define it directly, then I move this definition to CPP. So I can write X is equal to X and Y is equal to Y. Okay. Here I have refactor and move definition to rectangle, so it is moved here. What else? Okay, I can define this element, this setters for other attributes, but what about reading them? So now user can, for example, write rect set pose 1 1. So move, it moves element by, or translated by the vector. Here I set the absolute value for X and Y. But what about the situation when I want to verify where particular or where rectangle is? Yeah. So look here, with this set of methods, I'm not able to verify. So cout rect X. Yeah? So I can do it, yeah, because X is private. I can create a set of getters. So getter is a function which can be used to read variable. Yeah. If I use underscore, I can create a getter which is called the same like variable without underscore, and it returns. So now, when I have a getter, I can simply call this method to get value of x and to get value of y coordinates. Of course, you can, looking at this code, you can see, okay, so what for I have to return x? Maybe it would be better to make x public. But remember that if you make it public, you don't have the, you have to break the encapsulation principle. It's first issue. The second, if something will be dependent on x, for example, I'd like to verify or restrict the value of x, it is impossible to protect our object against improper modification. Yeah? So even it is harder, like in, you know, a hot drink machine. Yeah, it is okay. It can be easier that the user can, you know, have every resource and he or she can, you know, prepare its drink by itself. But okay, the problem is that this system is very hard in maintenance. Yeah? So we use setters and we use getter to let the user access element, some attributes. We don't need to give access to all attributes because some attributes can be, you know, internal attributes. So maybe we don't need or we don't want to give access for the user. Okay, it depends on the some assumption and specification. Okay, so let's go to the rectangle. So look, here every object is defined, you know, with default values. But sometimes I need to define object with some, you know, user specific values. So in this case, when I have the constructor like this, it means that after object creation, I have to call, for example, setter, set position. So it modifies the attributes of object rect. But I can overload my constructor. So for example, I can create, or I want to initialize object in creation time. So let's say that I'd like to set that the object dimension should be 1/4 and the position should be 0 - 0.5. So look, here I have 4 arguments. The first argument, okay, it's only my decision. The first argument will be the white, it will be height, and x and y. So I define this 4 arguments. So how to solve it? Of course, you can see that no matching constructor for initialization of C rectangle. So how to run it? Look, I can create a C rectangle with 4 attributes, 4 arguments. So I have another constructor, so it is overload. So I have 2 constructors of the same name, but they differ in number of arguments. So for compiler, they are clearly separable. No? So now look that this method or this definition is not, there are no error, yeah? So because the constructor has 4 arguments. So compiler tries, if I have definition like this, the compiler tries to find the constructor which arguments match the arguments which are passed here. So of course I have to create a constructor here. So I add definition. Oops, not here. I clicked wrong. So the same, I have constructor. So I have there are no type for constructor. I have class name and C rectangle, so constructor name. So the same for method, but in method we have also a method type specified. So look, I can copy this code. So I have initialization list, but instead of fixed value of height, I can specify that the value should be equal to value of argument. And here the value white should be equal to value of argument. And here the value x should be equal to the value of argument, and so on. Okay, other arguments are changed untouched. So they are default because the constructor doesn't modify them. Okay, so now I can have several methods and several constructors. I can add the method draw so drawing is quite easy for rectangles. So for int I equals 0, I smaller than height I plus plus. So we have nested loops for int j equal 0, j smaller than white, j plus plus, and then I have cout stdc out, let's say asterisk. Okay, to make it visible, I should use include IO stream. IO stream. So now it should work. And after the inner loop, I should see out std end line. So look, I have two rectangles. So when I call rect draw, maybe I call the rect set position, set size 2 by 2 elements. And then I call rect to draw. So I have two rectangles and I want to draw them. You can see that okay, the first rectangle is 2 by 2. Maybe I add end line here. And maybe here I create the rectangle of size 3 by 4 elements. So look, the effect is like this. Yeah, so the first rectangle is here, the second rectangle is here. So every object draw itself. Yeah? I'd like to tell you something about default attributes. I think I told you about default attributes of function. But look, if we have many attributes and we have the constructor which is used to initialize the arguments, in constructor we can set some attributes to be default. Yeah, so I can assign default values to all or to some arguments. So in this case, this constructor may substitute the default constructor, because when there are no values, the values which are specified here will be used. In this case, if we have a single argument, only white will be defined. If we have two arguments, white and height will be defined, and so on. Yeah. So when you create a constructor with default values, you don't need to create a pure default constructor. Yeah. So in this case, I can comment this constructor. So this definition works both for default constructor and for constructor with number of arguments from 0 to 4. Yeah? So defining the constructor like this, I can have also the version with 2 arguments. So in this case, white and height will be modified. In this case, X also. But remember that having the initialization constructor like this, to specify X and Y, you have to also specify explicitly white and height. Okay. So it still works. So let's go to the presentation. So most elements which are here were mentioned by me. So the names of methods and variables are a little bit different, but hope you cope with it. So here you have a class definition and some information about the private and access restrictions, and a full definition of the class. Here you have method definitions, so you can refer to this presentation after. Okay, now I'd like to tell you something about memory allocation for objects. So let's say that I have not a rectangle, but I have pointer to a rectangle. I have pointer to rectangle. So I have to allocate memory dynamically. So I can do it using new and see rectangle. So in this case, memory is allocated. And remember that in this case, also the constructor is called. So I can specify not only that there are no, pure type, but I can specify also arguments for constructor. So let's say 3 and 4. Yeah? So in this case, I create a rectangle, and the constructor, which will be called, will modify the white and height, comparing to default values. Okay, so if I want to use a prect, it's enough to, so it's the same like for structures. So it's enough to modify the selector from that to arrow. So maybe 5 by 5 and prect draw will draw this element. So you can see that this rectangle was printed. Okay, so there are no difference whether the type is structure or class. For all of these types, we can use a dynamic memory allocation. So here you have several information about constructors. So remember that this method can be called only automatically. So you can't call constructor by yourself. So you can, like a method, yeah? So methods, you can write the object name, that, and the method name, and you can call it, provided that method is public. But constructor is called only when the object is created, and it is called automatic. Depending on arguments, the proper constructor is used. So here you have example with initialization list and different ways of constructor calls I showed you just before. So for objects or classes, we have to specify not only constructors, but also something which is called a destructor. So comparing to constructor, when constructor is called on object creation, the destructor will be called just before the object will be destroyed or released. So I can have a method which will be called at the end, yeah, of the object life. So this destructor name is also class name, but there is a tilde between. So before, so to create a destructor, I have to write tilde C rectangle. Okay. So there are no type and no argument. So you can't specify the destructor arguments because it is called, without any arguments. So what should be done here? And in which cases? So I think it's very important to know when we have to create a destructor. So we should create a destructor whenever we have to, sweep something before the object will be destroyed. So looking at this case, do you think that we need, or do we need destructor here? No. Yeah, okay, so we don't need it because look, when the object will be destroyed, all fields will be destroyed too. So because these fields are allocated automatically, there are no reason to, to do something, yeah? So, but let's assume that I have C rectangle, but I have, for example, an array which stores some elements. And on runtime, so when the constructor is called, I do it in slow motion. So array is equal to new okay. So let's assume that this array is store. Okay, it should be integer. Okay, so it stores as many elements as the value of white is. Okay. I can do it also on initialization list array, and I can simply write the same. Yeah? So array underscore. So memory is allocated dynamically. So in this case, when the object will be destroyed or released, the memory is still allocated. So whenever you, inside the object, you allocate memory dynamically, you have to release it. So in this case, delete array. So in this case, the destructor is very useful. So look, from a user perspective, even the memory is allocated dynamically inside the object. From the user perspective, this object is treated as, standard object. So the object for which the memory is allocated, automatically. So if the object is destroyed, every memory is released. Yeah? But to do it working as the user thinks, we have to release memory at the end. So in this case, the destructor is required. What are the other cases? For example, we can have object which open a file. Yeah, so it's, for example, it writes data there, or it treats this file as a temporary file. Okay, it doesn't matter. But when the object is destroyed, this file should be closed. So in this case, we will use destructor2 to close this file at the end. But using attributes which are allocated automatically, there are no reason to use destructor. Okay, do you know any object which, okay, maybe I start from another point. Have you used objects so far? So have you used object-oriented programming, not from perspective of the developer or class developer, but the object user? So are you able to say which objects or classes have you used so far? in programming. Yeah, when we during our your laboratory classes or during lecture, yeah, I haven't told you that this is, you know, class and this is the object, because, you know, you learned how to use particular tools, but in fact, yeah. So okay, let's say we have CN. Of course, CN, it's a good option. So I have CN, and for example, we get a set of methods. So for example, precision. So this is a method of CN. So this is the object, and this is the method. The second example. STL, so I have vector. So look, here, default vector is created, but I have also a version which looks like this. So I have a version where I can pass in initialization, I can pass additional argument. So for a vector, there has to be another constructor which can be used when you pass a single argument. And looking at the vector looking at the reference to vector, you can find the section constructors. Yeah, so I have constructor, and here you can see all possible constructors. You can see that there is not two, but let's say more than 10 different constructors you can call. So in this case, I called the constructor I don't know which of this. Oh, okay, yeah, the constructor with size type. Yeah. So this constructor creates a vector of given size. I have also a version with constructor where I have two iterators. So I have iterator to first and the last. So when you have, for example, a vector 3, you can create this vector by specifying the value which should be copied. So I create a vector and I specify that it should copy elements from vector 2 from begin to end. Yeah? So this elements defines which constructor should be called. Yeah? And as you can see, there is a lot of okay, there's a lot of, you know, constructors. do you think that vector requires destructor or not? So does vector require destructor, or it can work without? So why? So the answer is that, look, when you create or use vector, you can resize it. So you can change its size depending on your purpose. So the memory has to be allocated dynamically, not statically, because when you create vector, the number of elements is undefined. So therefore, because vector allocates memory dynamically, when the vector is released, the memory should be released too. Yeah? So here we have destructor, and you can see that this destructor is defined here. Okay. So here you have slides which tells about the accessing to private attributes, and we hermetization or encapsulation is used. So I told you about this. Okay. Now I'd like to tell you something about operators. So let's start from a new example. Oops. Okay. So first, I'd like to create a class which define or which describe a fraction. And I like to use this fraction on a way how I can I usually use standard numeric variables like float, int. Okay, so let's assume. So let's start from use case. Usually, when we create a class, so there are two different ways how we can create or start creating class. First is to start from something which is called textification. So we have description of the problem and we extract some objects, their attributes, and we try to group them. So similar to the way how I created a rectangle. Now I'd like to show you a different approach. So in this approach, we start from something which is called a use case. Usually we, in designing process, these two approaches are mixed. But let's start from use case. So I'd like to have a class fraction, and I have object f, let's say f1 equal to 1/2. Okay, so this is the first line, which in fact defines what constructors do I need. I'd like also to make it possible to read value from the user by using, standard string operator. I'd like also to use the fraction to store, for example, result of operation, which looks like this. I would like to have also a fraction which can be cout sinus odd from the f3. To use this fraction as, argument for the standard functions. Okay, and I would like cout to have C fraction which led me to to print its value on output. So here you have something which is called a use case. And for every use case, so having this use case, I try to create a class which is able to meet these requirements. Of course, we start from a simpler approach. So instead of using Cn like this, I'd like to have function fget. So so this function will read required information from user input. In this case, I can have I can do it different, so I can write that f3 is equal. Maybe we start from this only this operation. So I have f sum f1. And after, when we define a sum, we combine it with these two elements. So I have f3 here. To print, okay, maybe to make possible to use in this on this way, I create a method which is called decimal. So this method converts the fraction into decimal fraction. And instead of using cout, I can have print. So look, we start from this use case, and then I will show you how we can modify our methods to use our object similar to standard embedded types. Okay, so let's start from the first line. So now when I want to create a class rectangle, so add new class. So I use, creator, but in fact, it's enough to create two files, so CPP and H file, and to create a definition. Yeah? So I have fraction class, and okay, now I have to create a rectangle, not rectangle. I have to define a constructor which is able to represent these two calls. Yeah? Okay, so I have fraction here. So include fraction age. So look, if in my declaration I have default constructor, the compiler accepts the use case, which looks like this. Yeah? But here I have also the use case where two arguments are specified. Okay, Mr. B guy. It's better to use pragma once, or in fact, the if not defined, defined, and if is equal to pragma once. Yeah? So you can use one of these elements. Usually in GCC, the construction like this is used. Yeah? Pragma once is also allowed. There are no differences, but here by default the creator use if not defined, define. Yeah, it may not be always supported, but okay, now for most of compilers it is accepted. Yeah, there was time where pragma once was used by Microsoft compilers, and it was not supported by, for example, GCC. But as far as I know, now it is accepted by all of these compilers. But in codes, when you look at the code from the standard library, you can find the construction like this. So it's, in my opinion, it's more popular. Okay, it's it has longer tradition. Yeah, so okay, so but remember, you should use these clauses, so it doesn't matter whether it is pragma once or if not defined, you should do it, because I showed you that if there are no clauses like this, it may happen that there will be a recursive including of header files, especially when some header files are nested. Yeah, so for your, to avoid some problems which are very hard to follow, do it. If you use creator, it is done automatically. Okay, so to meet the second requirements, we have to have a different constructor. So we have to have constructor which has two arguments. So int. Okay, what are these values? What does this values denote? So yeah, constructor has to be public. If it is not public, we can't create object. Yeah. So if it is private, calling private constructor. Of course, it is possible. Sometimes it is used to, for example, default constructor is declared as a private, because in this case, the user has to call, different constructor. So has to, for example, provide some arguments. But okay, maybe before I start defining constructor, look at the fraction. What should be, which attributes do I need? So what are the attributes for this object? Because, in use case, I can see only the interface here, but I can't see, I can, of course, even infer it, but I can't see the attributes. So do you have, or do you know what should be attributes? Two integers, of course. So what are, okay, so I have numerator and denominator, yeah? So yeah, I have int num and int them. Okay, so so again, in this constructor, I can define a numerator and the denominator. Of course, I can assume that instead of using two constructors, so default one and initialization constructor, I can use a single one, but I have to set default values for this element. So what should be default value for numerator? One. By default, we assume that when we create a numeric object, so by default it should be 0, yeah? So it should be 0. But what is the default value for the denominator? Yeah, definitely 1. Because if I have 0, I have 0 over 0, so it's not 0, yeah? We don't know, in fact, what is the value. Okay. So now, when I go to the refactor class definition, on initialization list, I can specify that numerator is num and denominator is then. Yeah, and I can delete default constructor. So look, now my Okay, so look, now my declaration or line 7 is without errors. So this declaration solves all problems with this line. So then I go to the next line, to line 10, and I have get. Yeah. So the aim of this method is to take values from the user input and assign them to numerator and denominator. So first, this is a method. So what is the type of this method? Void. Okay, it can be void. Then I have the name, and there are no arguments. Yeah? So look, now this line is clear. Yeah. Line 13. Look, I have sum. So the aim of this method is to sum my object, for which the method is called, with another object which is passed as an argument. So what is the type of this method? Look, F3 is fraction. So if I add two fractions, the result will be fraction, not float or double. So I expect that the result should be fraction. The name is, yeah, because it's, based on this use case. If here would be float or double, you can use float or double, but otherwise you shouldn't convert this fraction into different type. So I have sum, so this is the method, and the argument is also fraction. But good habit is when you pass object, you should always use const reference. Yeah. So remember to pass the object without copying it. So we use a reference when we want to modify this object, and const reference when we pass it as for read only. Okay, so look, line 13 is clear now. So we have line 16. So here we have method decimal, and it should work for sinus. So the question is, for this use case, what should be this method type? Yeah, it can be float or double. So let's say that it will be double. And I have method decimal. And look, the list of arguments is empty, so there are no arguments. Okay, sinus is underlined, so include CMAF. So look, now line 17 is clear, yeah? So finally, I have method print. So again, what is the type of print? Void. Can be void, print, no arguments again. Okay, so look, here I have a definition of my fraction. So it meets the use case. So there are no errors. Of course, when I try to compile it, there will be undefined reference error, because to use this class, so to compile the code, I have to specify or create a definitions of for get, sum, decimal, and print. Okay, we do it after the break. So now we have half an hour for break. So thank you for your attention, and see you in half an hour.